Okay, we recap yesterday's one. Yeah, so we have yesterday we have derived equation, yeah, for the pre-stress checking. Actually, it's checking the stress for pre-stress. Yeah? So if we want to check at mid-span, this is the formula. We have a formula, two formula, which is top fiber, ya, dekat atas di top fiber, and also bottom fiber, the top fiber. So the top fiber at the transfer, yeah. Remember yesterday what is transfer means? Yeah, when we stretch the steel and then we cut it. So transfer of stress will happen from the steel to the concrete. So that is called transfer. So during the transfer, we must calculate or check what is the stress happen inside the concrete. Yeah? So this is inside the concrete, not in the steel, inside the concrete at this section. So at this section, at this section. So this is at mid-span. So this is the stress that happen. The first one is due to self-weight. Remember self-weight, because during transfer, no external load applied, so it's only self-weight of the beam. So we have here stress. The stress is positive at the top, yeah? Meaning that positive compress. Positive means compress. So compress at the top here. So the formula is using the moment divided by ZF is equal M over Z. And positive, negative at the bottom here. Okay, and this one is due to the pre-stress force here. It is P, and then alpha is account of when we account for the loss, and the loss is happen at both. The first one is due to during transfer is due to. Can we have a look at the book? Due to elastic shortening of concrete. It is due to elastic shortening of concrete. Yeah, meaning that when we cut the wire, remember yesterday the concrete will be shortened. Second one is due to slip movement of tendon during anchorage. Yeah, when we cut and we put anchorage, sometimes it will slip. So that's why it's the movement happen here. So the P will also become less. And then relaxation of pre-stressing steel. Relaxation means after we cut the steel will, will relax, and it will reduce its strength. Okay. Sorry, your friend want to join in. Admin. Oh, okay. And the last one is friction at the bend due to curvature of tendons. So this curvature will also induce the friction between the concrete and the tendon here. It will cause also the loss of the P. Let's say the ultimate strength for the P is 1000. So we need to stretch the steel until 80% of them, meaning that 80% is 800 kilonewton. And then after we cut the steel, the P that the net P will be less than 800. It is called loss. Therefore, we need to put alpha here. Okay, alpha is the loss, account for the losses, divided by Z1. Z1 is I over Y1. So you need to remember this equation here. Z1 is equal I divided Y1. Z2 is I over Y2. Those at the top of, this is the neutral axis, yeah. You can remember last time when we draw stress, there will also, there are neutral axis here. Okay, so the top stress, it will be divided by Z1. The bottom stress will be divided by Z2. Also due to, stress also happen due to eccentricity, yeah? Because at the midspan, you can see here the tendon is curved. Yeah? So at midspan, it got distance E. We call it E here, eccentricity. So the moment is P times E. Yeah? P times E. So for the moment, for the eccentricity, the moment will result negative stress at the top fiber, negative here, okay, and then positive at the bottom. It opposite of the self weight, and then we must add up with the force if we applied at the center. Although the P now is at the eccentricity, but we must also take it into account if P applied at the centroid, yeah, at this neutral axis. So alpha P over A. So we can get this formula. This formula is for the top fiber. We must sum it up. Sum up here. We got MI divided Z1. Yeah, this one minus plus. Must be greater because at the top we assume that this is our assumption that during transfer, at the tension part of the beam here, this at the bottom of the beam, it is because of when we apply the external load as well as self weight, the bottom here will crack. Yeah? For the normal concrete, it will crack during the service, will crack at the midspan at the bottom. So in pre-stress, we don't want that this section crack. Yeah? This point, we don't want this point to be cracked. Here, we don't want here crack. Yeah? Therefore, this is our assumption. It must be positive here, must be positive. Therefore, when we add up all of the stress here, the bottom one must be positive. Yeah. So we have FCT. Yeah, this is the allowable. This term is the allowable concrete in tensile in concrete. Concrete compressive in concrete during transfer. This is tensile in concrete during transfer. Okay, so for the top one, yeah, we assume that this must be greater than minus FTT. FTT is the tensile. So in pre-stress, we assume that, sorry, your friend want to join in. Okay, we assume that in pre-stress concrete, during transfer, the top fiber here must be greater than the tensile stress allowed in the during transfer. That is called FTT. Minus mean tensile. When you draw the diagram, minus, it shows that it is here, this side. This side is positive, this side is negative. Okay, so our assumption that the positive plus negative plus positive, at least it must be equal FTT or greater than that. Yeah, that is the code mentioned about the limitation. Yeah. Okay, we have here equation 1, equation 2. Then this is during the service. Okay, during the service, we have external load and self weight. Therefore, the stress will also due to the load here. MS, we call it as WS, and it result MS. And then this is due to eccentricity. You can see here eccentricity, opposite of this, plus beta PA. These are two. Want to join in. Okay, so during service, there will be also losses here due to the first one is creep and shrinkage. This is due to creep and shrinkage of the concrete under sustained compression. And the second one is relaxation of the pre-stressing steel under sustained tension. Creep and shrinkage. What is creep and shrinkage? Creep and shrinkage is the like deformation, deformation of the concrete. Concrete will shrink. Shrink is in a short term, but creep is a long term. But here, loss is due to the long term. The concrete will shrink or creep over the long term period. Therefore, it will reduce the P that we applied here. So beta is the constant to account the losses due to long term during the service. Okay, therefore we have another equation at top fiber. This is the top fiber and the bottom fiber. Yeah, and the assumption we must assume that at service at the bottom here must also zero, at least zero, and there's no crack. If we say here zero, meaning that there's no crack. Therefore, in the code, at the bottom here, it must be greater than tensile during service. Yeah, here. At the top, it is mass less than concrete during service. The compression here. Okay, so Rais, join in. So we have, maybe we have two types of diagram, something like this or like this, because FTS, according to the code, FTS is equal to 0. Yeah, you can see here, this is the limit, stress limit. This is stress limit, meaning that here we got during transfer, this is the transfer, and this is service. Compressive and tension. Okay, so you need to understand that during the transfer, okay, during the transfer, okay, just now, okay, during transfer here, so we got bottom is compressive, the top tension. Yeah, this is tension, this is compressive. So the tension will happen at the top, at least at the top. So this is the top, located at the top. You see the top. Top fiber. Okay. Oh, sorry. And this is bottom fiber. Okay, so the bottom fiber, the value must be 0.6 FCKT. Yeah, T means time. During transfer, what is at what day? Maybe in the factory, the steel will be cut at 1 day, 3 days, 7 days, and so on. It's depend on the concrete strength. Yeah? So now we know that during the transfer, Remember just now the transfer, we have the something like this, okay? Okay, we have diagram like this, meaning that at the top, it must be at least FCTM, yeah? The value is FCTM, so what is that? FCTM, okay? And then at the bottom, here, the value is 0.6 FCKT. 0 FCKT. So this is at the transfer. Okay. While at the service, yeah. So the service is upside down from this. Yeah? At the service, sorry, where's the drawing? Okay. During service, we want the bottom. The bottom will experience tension, and for the pre-stress, we want to cancel the tensile stress here, meaning that it is 0. Yeah. So we get like this. Okay. So here is FCTS. FTS, tension service, is equal to 0. Okay. And at the top, it is equal, this is FCS is equal 0.6 FCK. Okay. So the value must less than this. Okay. Here also, here must be greater. Okay. This one must be greater than FCTM, and this one must be less. So this is FCT, yeah, equal, yeah, and the value must be less than. Okay. All right. So what is FCTM? Yeah? So we need to refer to the and show. Okay. Okay, we have a FCTM. Need to erase first. Okay, FCTM. View, manage, edit. Okay, FCTM here. It depends on grade of concrete. Yeah, so if your FC, let's say your grade of concrete is 35, then you got 3.2. It's depend. Okay. So back to our oh sorry, I have already erased that one. So need to draw again. Yeah. So this is the transfer. Okay. So this one is FTT. FTT is equal FCTM, right? Must be greater, the value. This is the limit. Yeah? The limit is FTT. Yeah? FTT. Then the limit at the bottom is FCT is equal 0.6 FCK. KT. Okay, this is transfer, while for the service, yeah, FTS, you can see here FTS, FTS, yeah, must be equal to 0. Okay, if we talk about FTS, the diagram should be like this, yeah, but in this stress limit, yeah, because FTS is equal to 0, so it must be equal to 0, like this. Okay, therefore here is FCS equals 0.6 FCK, while at the bottom here is 0. Yeah. So this is the service. Yeah, this is during service. So this is during transfer. Okay. Someone to join in? Okay, Umi. Okay, now we have understand that the stress limit in a pre-stress is, the diagram is like this. FTT at the top fiber, FTT is equal to FCTM. The bottom fiber, FCT is equal 0.C FCKT, while for the service, top fiber will experience compression at the bottom, tensile, but tensile does not allow here. Therefore, because the value here is 0, meaning that no crack at all. It shows that here the crack will not allow, no cracking. Okay, that is the stress limit. Okay, so now what is 0.6 FCK? Yeah, this one. What is FCK? It depend on when the wire being cut. So we can refer to the book. Okay, the book here. Where is it? There you go. So this is the sample of the FC. This is grade 30. The grade 30. Let's say we use grade 30. Let's say we use grade 30, C30 here. Okay. So the characteristic is 30. Okay. Now FCTK. FCTK means at transfer, the strength of concrete during when the wire will be cut. Let's say you will cut at 7 days, therefore the FCTK will be 20. So if the tendon are cut at 7 days, this FCTK T, transfer, is equal 20 Newton per millimeter square. Okay, that is the meaning of FCTK. Therefore, here is equal 0.6 times 20. Okay, here, right? FCTM, we must refer to the table in the formula booklet. Concrete mean tensile in the concrete. Okay, once we have understand this, so we can, you know, check the stress in the prestressed section. Okay, let us see example. You need to erase first. Okay, so we have example 13.1 at 13.1. Example 13.1. So we have a prestressed beam, yeah, prestressed beam, post tension. Yeah, this is post tension, simply spotted post tension concrete beam with dimension shown in this figure. This is I beam. Yeah. Okay. For your information, prestressed section will be very sometimes it's just a rectangular section, sometimes T, sometimes L. It depends on the element. So in this example, we have I section. And let's say now we have a tendon, one tendon located at the bottom here. Yeah, located at the bottom. And if you read the question, it has initial pre-stress force of 4,000. Yeah, 4,000. The initial pre-stress is in your book is 4,000, but in my book is 3350. I have 3350. The old book 3350. Okay, and during the transfer, the loss is 10%. Therefore, the value of alpha is 0.9. 100% minus 10%, so you got 90, 0.9. And then the short term also, the short term is 20%, so this is 0.8. Typo error here there. This is 0.8. 0.8. Okay, eccentricity, the value is 500. Although the question doesn't give you the diagram, the free body diagram in the longitudinal section, but you need to imagine. Yeah, so E at the midspan will have the value of 500 here. And the service load, we have 17. The service load, the service load exclude of the, not including the self weight, excluding self weight. So it's excluding self weight. Then, so that's all the information we have. And then we got the dimension. Okay. And the section properties, if not given, you need to calculate. Yeah. So I think you know how to calculate. Yeah. Using how to get Y1. But I think usually in the final exam, we will give you what is the value Y1 and Y2. Yeah. So Y1 is the one from, okay. Okay, so we have a centroid here. Yeah, we have a centroid. Let's say the centroid is somewhere here. Yeah, this is the centroid or neutral axis. Okay, this is the neutral axis. Neutral axis. Yeah. So Y1 is from the top fiber to the neutral axis. Yeah. So now we have Y1 from here, top fiber to the, yeah, this is called Y1. Okay, this is Y1. And from here to the bottom fiber here is called Y2. Yeah. I think you have learned in the strength of material, that one, this one. Okay, this is Y2. So you got Y1 and Y2 here. Okay, and the value is 516.9. Y2 is 733.1 here. Okay, someone want to join in? Okay. And I, the modulus section. Yeah. It also given if the shape is complicated, this is considered as complicated. So I is equal 73.6. Actually, for the pre-stress section, we have a handbook. Yeah. If your section is I, T, L, something like that, they already provide the Y1 and Y2 and the area as well. So, but you need to know which one is Y1 and Y2. Yeah? So Z1, you can obtain by dividing I over Y. Z is equal IY. Z is equal I divided by Y1. So you have the value there. I divided Y2. Okay, so you got the value here. Okay, so we have already obtained the section properties and section modulus. Yeah. Okay, solution. Yeah. So what is the question actually? The question asks you to determine the stress distribution, yeah, determine the extreme fiber stresses at midspan, and midspan here. The question asks you to calculate here. What is the stress distribution at the midspan? And also check this stress, whether the stresses you obtain are within the allowable values. Okay, so we need to find what is the stress at the top fiber, at the bottom fiber during the transfer and also service, and also check whether it is within the allowable limits. Okay. Now go the solution. Yeah. Okay, for the solution, sorry. For the solution, you can begin with the stress limits. Yeah. So in this question, in this solution, we begin with the stress limit, or you can directly calculate the top and bottom fiber. Okay, so according to the solution in the book, we begin with the stress limits. Okay, now we need to find what is the stress limit. As I mentioned just now, we must refer to table 8.3, the stress limit. Yeah, the stress limit. So we have top fiber. Yeah, top fiber. Here we got FCT, so top fiber. Okay. And show. Oh, sorry. What happened? Oh, where is the... Oh no. Okay, now we have, I need to find this. Okay, this is midspan top fiber. Okay, top fiber is called FTT, and the bottom fiber is, okay, we need to copy this, okay, to the solution here. Okay. Okay, okay, erase first. So we have the stress limit from this table. Okay, okay. FTT, top fiber is FTT. Yeah? Okay. So we have now top fiber is FTT. So this is top. Sorry, this is top. This is bottom fiber. Okay. And this one is top fiber and bottom. Okay. Now, okay, as I mentioned just now, during the transfer, we want bottom fiber to be positive. Yeah? And if you can remember, just now I draw it. Valentine want to join in. Sorry, I need to admit Valentine. Okay, let us draw. Yeah. So for the transfer, remember the transfer. Okay, transfer, we must have the bottom one to be positive. Yeah? So this is the bottom one. So don't get confused. At the transfer, we want the bottom one to be positive, and the top one can be negative, or tensile, can have tensile, but with the limited value. So the value now is 2.77. Yeah, 2.77 is negative, yeah, because this is tension. Yeah, it must be negative here. So the top fiber is 2.77 here, negative, and the bottom is positive 16.8. Okay, the value 16.8. Okay, so this is at the transfer. If you confuse, just remember here. Okay, sorry, if you confuse, remember the process here. Okay, look at this diagram. Yeah, this is during transfer. Yeah, during transfer, the bottom, yeah, the bottom part here must be positive. Yeah, because that's why the beam bend up like this or camber. It's the camber form, meaning that at the bottom here it will be compressed. If you can see here, positive, because this is compression happen here, and tension happen here. Okay. All right. Back to our example. Okay. Need to erase first. Yeah. So this is during transfer. And at the service, okay, and at the service, we want the bottom part to be 0. Yeah, the bottom part to be 0. So now we have here 0 here. And the top one is 24. Therefore, when you check the cross section, when you check the stress at the cross section, during the transfer, the bottom part must be has value maximum 16.8 and a minimum value 2.7 or 2.8. Meaning that if you got 0, it will be better. If you got 3, meaning that your beam is failed. Yeah? Okay, therefore this is the stress limit. Okay, now we have to go to another step. Okay, the next step is that we calculate the loading and bending moment. Yeah, because during the calculation we need the value of mi and ms. Yeah? This value. Okay, so mi is due to the beam self-weight. Yeah? So the area of the beam is 0.46 times with the density of concrete. Yeah, this is as usual, concrete reinforced concrete. The density is 24. Just multiply it with the area so you can get the loading. Then we can get the moment, WL square over 8. Why using this formula? Because this is simply spotted. This is simply spotted. Because this is simply spotted beam. Simply supported beam. Yeah. Simply spotted beam. So we have moment WL square over 8. Yeah, the moment is WL square over 8 here. So during the exam, you need to be very careful, yeah, with your beam configuration. If your beam is, if your beam is cantilever, yeah, your beam is cantilever like that. Yeah, so what is the maximum moment here? Yeah. If you have UDL, yeah. So it must be the maximum is moment is equal WL square over 2. Yeah. MI or MS must be equal WL square over 2. This is square over 2. This is the L. Okay. For the MS, we need to add the total self-weight and the service load. This is the service load. Unfactored load. Service load means unfactored load. So we have here 11.6 and the given service load is 17, so we have 28.6, so we can get the MS. Okay, then we use this formula. How to get this formula? Yeah, this is from our derivation yesterday's. We have a which one? Okay, we have here copy here, and then okay. Okay, this is our formula yesterday. So top fiber in the solution in the book, it called F1T, yeah, F1T, meaning that at the top here is F1T. Here is F1T, yeah, F1T. F1T, here, F1T. Okay, so alpha, we know the alpha value 0.09. P over A, P, the value is 3350 times 10 to the power of 3 because this is kilonewton. We change to the Newton because we want the value in terms of Newton. Divided by the A must be also in millimeter minus alpha PE divided by Z1 plus MI divided by 1. Okay, MI Z1. So actually you don't need to remember the formula. It's just that you need to understand the derivation of the stress distribution at this section. Yeah? So we have here 2.27, meaning that it is positive. Yeah? From this calculation, we got positive. So it is positive. This is positive side. Yeah? Positive. And then bottom fiber, yeah, bottom fiber, we have this formula. Okay, here you can see here the same formula. Okay, now we have F2T. In the book, it is called F2T. F2T. Copy paste F2T here. F2T. T means transfer. So again, we calculate again. Yeah. So we have 12.54 here. So it is positive, meaning that positive. So if you remember just now, this is our limit, yeah, the limit for the stress during transfer. Yeah, the diagram in the blue one. So meaning that we have 2.27 is greater than 2.77. Yeah. So it is allowable, and the bottom one is less than 16.8. It is also allowable since this is less than this. Okay, then okay, we complete the stress distribution at the transfer, during the transfer. And then the next one is top fiber. Yeah, top fiber. Let's say now, remember yesterday's one, top fiber during, okay, so we have this formula. Okay, we have this formula. Copy. Now we have formula we derived yesterday's top fiber MSZ1, okay, minus beta PEZ1 minus PEZ1 plus beta P over A. Yeah. So we have already got the value we calculated earlier. Then we need to replace in the respective symbol here. Beta we got 0.8, P is 3.50, and so on. Then we have the value 12.06 here. F1TS is called F1TS here. F1S, sorry, F1S. So this is stress here, F1S. And the bottom one is F2S. F2S. F2S is equal, see our yesterday's equation, minus MSZ2 plus beta PEZ2 here, beta P over A. So we got the value negative 0.9. Yeah? Okay, this is that the one that we obtained. Okay, this is the limit that we obtained, we calculated earlier. And we obtained that for the top part, yeah, for the top part, the compression part, we got 12.06 is less than 24. Yeah, it is allowable value here, within the allowable value. But at the bottom part, yeah, at the bottom part, it is negative, meaning that there's a crack. It shows that there's a crack, while the limit says no crack at all or zero. Therefore, during the service, the beam will have a crack here, and it cannot be used. We must redesign. Yeah? So here is not allowed. Okay. Therefore, the question also asks you to check whether the stress obtained just now is okay or not okay according to this the stress limit. So we have found that at service, yeah, at the bottom part, it's not okay because it is greater than 0.000. We need 0 at this one. So this is not allowable here. So if you want to answer this question, it is enough. You just said at the end here. You just comment at the end here, okay, whether it is okay or not okay. Just like in the example. All right. Okay, this one is actually here. This is not greater, this is less. This is less. Okay. Sign convention. Okay, that is the solution for our example here. Example 13.1. Okay, we go to the next example. That is example 13.2. Yeah? Example 13.2 is similar like 13.1. It is simply spotted and post tension. The L is 20. Okay. The characteristic strength of concrete given here, and FCI. Yeah, the FCI is 30. FCI is FCTK. Yeah. This is FCTK actually. Forgot to mention just now. This is also FCTK. FCTK. Okay. FCI is equal FCTK transfer. Yeah, the value of concrete strain during transfer when you cut the wire or the tendon. Okay, the service load is 20, the pre-stress force is 2000. eccentricity is 500, the short-term losses 0.9, long-term is 0.8. Okay. Okay, what is the question? This question is that select a suitable concrete section. Okay. Here, the section of concrete is not given. Therefore, we need to find what is the suitable one. If you assume that the section is rectangular, and the second one is standard section. Okay, standard section means I section and the like. Yeah? Okay, now we need to find what is the section suitable for this value. Okay, right. The first step we do is that, similar like just now, of course, we need to calculate the stress limits. Okay, the stress limit will depend on the value of FCK. Yeah? So FCK just now is 50 and FCS is 30. Therefore, FCT is equal 18. Yeah? So 18. So, oh, sorry. Where is it? Eraser. Okay. Stop. Okay, stop. So now we have okay. Okay, where is the diagram? So we have a new value now. Okay, so for the transfer, remember the transfer bottom must be positive. Yeah, the bottom one is positive, and the top must be negative. Oh, there are a lot of tension at the top. Yeah. Therefore, the value now is 18 at the bottom here. 18. And the top tension FTT is equal to 0.9, 2.90. Yeah, this is negative, positive. Okay, so for the service, remember for the service, yeah, the bottom part must be 0. Yeah, because the tension is not allowed. Yeah, so the bottom must be 0 and the top must be positive. Remember here? So we got here 30 and the bottom is 0. Okay, that is the limit. The limit, at least the limit must be as shown or calculated here. Okay. Izatu Izwa join in. Okay. Now we have to calculate what is the cross section. We need to determine what is the cross section. Okay, before we determine the cross section, we need to we need to determine what is Z, before we calculate. Here we got we need to try. Okay, let's say we try B is 300, H is 1400. Let's say B is 300 and H is 1400. So we got the area and we got the section modulus. Yeah, this is because this is easy because our section is rectangular section. So we got the formula Z is equal Z2 BH square over 6. Okay, the bending moment due to this section, yeah, due to self-weight, so we can calculate the moment MI and also the total service load, yeah, and also the service moment load, yeah. So how do we calculate? How do we get the suitable section, yeah? If you can see the solution, we have this formula, yeah, Z1 and Z2. Okay, all right. Back to our here. Okay. Remember yesterday we have derived equation 1, 2, 3, and 4. Yeah? This equation. This is equation 1. This is called equation 1. This is called equation 2. Yeah? Right? And this is equation 3. Okay. This is equation 3. Equation 3. And this is equation 4. Okay. So we have derived 4 equations, 1 and 2 during transfer and 3 and 4 during service. Yeah? Then, okay, now we need to find the Z, yeah? The Z, Z1 and Z2. Remember just now we need to do the trial and error. Yeah. So if you do trial and error, we don't have the, we will have a very long calculation. But by arranging this formula, yeah, arranging the formula 1 to 4, and we try to get what is the Z1 from this equation. Okay, so rearrange the formula 1 to 4. So we have 5 and 6. Just rearrange. Yes, we got this form and also this form. So we have Z1 and Z2. Okay, so from the transfer, we have Z1 also and Z2. Yeah? So we have another set 5, 6, 7, 8. Yeah? With the unknown Z1, unknown Z2. Yeah? At the service also we have unknown Z1 and unknown Z2. The phi, the value of alpha, P, E already known, already known. Yeah? Only Z and A, Z. Okay, the Z, we don't know Z. Yeah? The next step, we want to get the value of Z1. Therefore, we need to times beta for the equation 5 and times alpha to the equation 7. The objective is that to eliminate the Z2. Yeah, we want to eliminate Z2. Okay, so we have here Z1. Yeah, from 5 and 7, 5 and 7, 5 we have Z1, and 7 we also have Z1, but we have alpha and we have a beta. Yeah, to eliminate one of them, we need to times here beta and here alpha. So we can get the value of Z1 here. Yeah. So thus we call it as equation 9. And another one, Z2, will be obtained by multiplying equation 6 is beta, equation 8 with alpha. So we can eliminate Z1. Therefore, we have the Z2 here. Okay. 6 and 8. Let's see, 6 and 8. 6 and 8. Yes, 6, we have Z2. 8 also, we have Z2 here. This is Z1, typo error, Z2, okay. So this is Z2. This is Z2, typo, this is Z2. So we will eliminate them. So you get here Z2. Okay. By using this equation 9 and 10. Okay, 9, 10. Here. Sorry. Here. Z1, top fiber. Yeah. Alpha, we have the value. MS, we already got the value. Beta, we have the value as well. So everything we have the value except Z1. So we have Z1 here is 47.77 times 10 to the power 6. So we have, this is the value that we obtain. And Z2, we have 97.25. And this value must be compared with the actual. Our actual here is this one, 98. Yeah, 98.0. This is, we try one section. So we got Z1 and Z2, 98. And then by calculating here, we got 47. 47.77 is less than 98. It's much, much less than the actual. Therefore, this one can be used for the beam. Yeah? This section can be used since the Z1 that we calculated is less than the value Z1 that we using the trial section. You can also try another size, yeah? As long as your Z1 and Z2 is greater than the calculated here. Okay. Okay, now the question also asks us to calculate by using the standard section. So now, what is the standard section? Yeah. Okay. Look at the book here. If you refer to the book, we will see this diagram. Yeah? So this is called standard section, yeah? That we usually use in a construction. It is I, but it is not perfect I. It's got something like this. Okay? So this is called standard section. And for the pre-stress construction, they have already given the value of the, let's say, D, the depth, the neutral axis, Y1, Y top, Y bottom, the moment inertia, the section modulus also given in the handbook. This is just example. This is taken from the pre-stress handbook. For this section, this is the value. So in order to answer this question, actually, we did a handbook. Yeah. So the value that we obtain here is actually from the handbook. Yeah. For the PCAM BIM M6, it is the name of the section given in the handbook. Z1 and Z2 also given, the value already given. Yeah? So we just need to, the area also given. So we just need to calculate WI and MI and also WS and also MS. So don't worry, yeah. If final, yeah, in the final, we will give you the section and the value of Z1 and Z2, as well as the A and Z as well. Yeah? You can see here, Z also given, yeah? Z, Z1, Z2, Z top, Z bottom is, Z top means Z1, Z bottom is Z2. So everything already given. So all we need to do is that just calculate the self-weight due to the section and the total service load. So having calculated of all this, and then we get the value. So our next step is that calculate Z1 and Z2. So this is the calculated one. If your calculated here is less than the actual, meaning that the one that you select here is can be used, yeah, for the section, for the bib. Yeah. For example, here we got 32.25, while for the section that we try, Z1 is 75, meaning that this is much bigger than the Z1 obtained from the calculation, from the theory. So therefore, we can use this section. Okay, we have reached the, we had complete, yeah, the example 13 point, what is it, 13 point what here? 13.2, I think. Yeah, so any question? 13.2, yeah? Any question? Ada soalan?
Doctor, sorry, Ana tanya. For the stress limit cut transfer, I want to ask for the top fiber one. The FCTM, we have to obtain from the table 3.1 in the Eurocode, or we follow the formula like Dr. Sean is like 0.3 times 0.3 times FCI times power 2/3. Because I see in the Eurocode there is two versions, right? For the top fiber, the FTT, FCTM.
Okay, we refer to this table, table 8.3.
Yeah. I mean, because I see the transfer like the tensile, the FTT there equal to FCTM. So we refer back to the how we obtain FCTM, right?
Yes.
But I see to obtain FCTM there is two way, because I see just now in example 3.1 and in example 13.1 and 13.2,
Yeah.
dia macam lain lah. Satu dia FCTM dia macam kalau configure tu dia 30, so dia obtain from the table, so FCTM equal to 2.9.
Yeah.
Satu lagi dia macam dia pakai formula yang macam kat example 13.1 dia pakai 0.3 times FCK power 2/3. Dia ada dua, so kita kena pilih
which one? I cannot get it.
Okay. Maybe Doctor, you show again the example 13.1.
Okay, this is 13.1. Okay.
I think maybe next slide. Because I forgot. This one, because I see for the stress limit and transfer, the top fiber, the tension part, FTT equal to FCTM. Then the example use the equation 0.3 times FCI power 2/3 equal to negative 2.77.
Oh, this one. Okay.
Because I see the another way is we just directly obtain the value from the table, because I remember that for this question the concrete grade is 40 lah. So if we directly obtain the value, it's like 40 and FCTM 3.5. So the value like dia macam lain lah. So dia macam ada dua cara. So saya tak pasti.
Okay.
Lagu mana?
Okay, we need to check with the, okay, I have the book here. What is the stress limit? Okay, the stress limit. Okay, the stress limit here. Okay, this is the convex limit specified. Okay, this is according to the EN, yeah? EN. So if FCTM. But in this calculation, okay, I understand. Okay, now so we have, so we don't actually, if according to the table, right? So we straight use the FCTM, right?
Yeah, I mean this.
Ah, okay. Ya.
So dia dua-dua boleh ke apa?
Satu saja.
So kalau macam tu kita directly obtain the
Ya,
value lah from the
directly,
table
ya.
according to the concrete grade.
Yes.
Okay.
Yeah.
Thank you, Prof.
Sorry. Thank you very much. Tak perasan. So the value is, what is the value actually? Yeah, FCTM.
For the concrete graph, I remember this question is 40, so FCTM will be 3.5. Because Prof, I asked this because I see at the end of the table, there is one column called analytical relation. Dia pun ada formula shown in Dr. slide, 0.3 times
Okay.
FCK, it's power
Okay.
2/3.
From the table, right?
Yeah. Dia dua ada. So I agak confused sikit lah.
I will. Here, FCTM, yeah?
Yes. Yeah, that in the last column there is also this equation.
Analytical relationship. FCTM 0.03 FCTK. Oh, this is FC, not clear. What is it? This is 0.3 FCK. This is 0.3 FCK. If you, I know. This is obtained from the laboratory, right? You do a lot of tests in the lab, and then you get the FCTM. You do the relationship between FCTM and FCK. Yeah. You can also use this expression if you don't have this table. If you don't know the value. Let's say now we have FCTM directly can be obtained 3 point. Let's say you use 40, so you can get 3.5, right? FCTM. Okay, but if you don't have this value, you can use the value of FCK here, FCK 40 times here 0.3 times FCK to the power of 2/3. Okay, let's see here. Okay. This is also can be used. This also can be used if you don't have the value you don't have the table about FCTM.
Okay, I understand. Okay, thank you, Prof.
Doctor, sorry to interrupt. I think this is a time issue, when we get 2.77, we get from the characteristic strength for 7 days. If we get 3.5, there is a characteristic strength of the original grade 40 N per mm squared.
Wait. Here is FCK. FCK should be FCK. Yeah.
Yeah, if you got 2.77, you get from the 7 days characteristic strength.
Yeah. It's not 28, right? 30, right? Betul tak?
28.
Huh?
40, Prof.
For 7 days.
Not for 7 days.
For 7 days,
Yeah,
it's
28.
2.77.
Yeah, 7 days. Okay. Betul lah, betul. Okay, you are right. Yang lain paham tak? So meaning that this FCTM, you cannot refer to the table here. Because this table is referring to the 28 days. Am I right? FCTM, this FCTM is referring to the 28 days when you test it at 28 days. But we can use this formula, the same formula, but here is FCT grade of concrete at 7 days. Yeah, 28.
Okay, understand, doctor.
Okay. So we will have one question in final exam. So we have section B, we have 3 questions. So you choose 2 out of 3. And the first question is beam. Second question is slab. The third question is, this one. And this is simple, actually, if you understand. So I think to familiarize about pre-stress, I think you need to do the exercise in the book. Also, if you have past year's question, it's better. You can try. Okay, you can try problem 13.3, but this is very simple. Okay, if you have time, just try the past year's question. Usually the question will, ask you about the advantage of the pre-stress, the difference between normal concrete and pre-stressed concrete, and also calculation like this. But the difference is that we don't know the cross section. Okay, any question? Okay, if there's no question, so I think the attendance, academic kehadiran kelas. Attendance slide in. Okay. Test 2 will be after 15. After 15. I will give you the exact date later. Because next week I have, laboratory class next week. And the next weeks also got laboratory. And then I will be free after 15. Muhammad Asrik. Muhammad Asrik. Muhammad Asrik dengar tak? You ada nak tanya kan? Saya tak faham you tanya. Muhammad Asrik. Okey, ada nak tanya apa-apa tak? Kenapa senyap je? Rais, Muhammad Rais ada? Ada soalan tak? Tak ada eh?
Setakat ni tak ada doktor.
Ya. Okey, senyap je.
Pagi
Okey.
doktor, pagi.
Okey. Ni Muhammad Ashrik di mana? Muhammad Ashrik dia ada tanya saya tapi saya tak faham apa dia tanya. Tapi dia senyap je lah. Kat mana dia? Macam mana nak cari dia? Muhammad Ashrik, kalau you dengar, you WhatsApp saya lah. Okay, if there's no question, yeah, so we end up our class. Kita pun dah habis kelas. Okay, so if you got any question or regarding to the final or project, you can arrange one session or two session using the Zoom. You boleh kumpul lah banyak-banyak siapa nak tanya. Okay, kalau siapa ada buat solution ke apa, you tak faham, you nak tahu betul ke tak betul, you boleh share dekat WhatsApp and then kita boleh Zoom lah explain. Okay. Thank you.
Okay, thank you doktor.
Okay.
Thank you, Doctor.
Okay.